Fermentation is one of the oldest food technologies in human history, yet it remains one of the most powerful and underappreciated ways to transform grains into foods that are not only more flavorful but also more nourishing and easier for the body to use. Rather than simply preserving food, fermentation actively reshapes the chemistry of grains. Through the action of bacteria, yeasts, and naturally occurring enzymes, fermentation reduces compounds that block nutrient absorption, increases certain vitamins, and predigests complex carbohydrates and proteins in ways that modern digestive systems often find gentler. When viewed through a positive analytical lens, fermentation is less about fixing grains and more about unlocking their full biological potential. One of the most important changes fermentation brings is the reduction of phytic acid. Phytic acid is concentrated in the bran of grains and binds minerals such as iron, zinc, calcium, and magnesium, making them harder for the body to absorb. During fermentation, naturally occurring phytase enzymes, either already present in the grain or produced by microbes, break down phytic acid into smaller, less inhibitory compounds. This process does not eliminate minerals, it frees them. As a result, fermented grain foods often deliver more usable minerals than their unfermented counterparts, even when the total mineral content appears similar on paper. This is particularly meaningful for populations that rely heavily on grains as staple foods. Fermentation also enhances the vitamin profile of grains, especially B vitamins. Microbial activity can increase levels of folate, riboflavin, niacin, and in some cases vitamin B12, like compounds. While fermented grains are not a primary source of B12, the increase in other B vitamins supports energy metabolism, nervous system health, and red blood cell formation. At the same time, fermentation partially breaks down starches and proteins, improving digestibility and often reducing bloating or discomfort. This predigestion effect is why many people who struggle with conventional bread or grain dishes find fermented versions noticeably easier to tolerate. The contrast between sourdough bread and commercial white bread illustrates these benefits clearly. Commercial white bread is typically made with refined flour, fast-acting yeast, and short fermentation times. This produces a soft, uniform loaf but leaves most phytic acid intact and results in starch that is rapidly digested. Sourdough bread, by contrast, relies on wild yeasts and lactic acid bacteria and ferments over many hours or even days. The acidic environment activates phytase, reduces phytic acid, and alters starch structure, often leading to a lower and more gradual blood sugar response. From a positive perspective, sourdough also develops organic acids that slow gastric emptying and enhance mineral absorption, while creating complex flavors that encourage slower, more mindful eating. Fermented rice batters, such as those used for idli and dosa, provide another compelling case study. Rice on its own is highly digestible and often produces a rapid rise in blood glucose. When rice is soaked, ground, and fermented, usually with lentils like urad dal, the nutritional profile shifts dramatically. Fermentation increases B vitamins, reduces anti-nutrients, and improves protein quality by balancing amino acids between rice and legumes. The resulting batter cooks quickly and lightly, producing foods that are airy yet satisfying. For many people, idli and dosa feel easier to digest than plain rice, not because they contain less carbohydrate, but because fermentation has already begun the digestive process outside the body. Nixtamalized corn represents a unique form of fermentation-related processing that fundamentally transformed public health in cultures that relied on maize as a staple. Cooking corn in an alkaline solution, traditionally lime water, changes the grain at a molecular level. This process releases bound niacin, preventing pellagra, a disease that plagued populations consuming untreated corn. It also increases calcium content, improves protein quality, and enhances flavor and aroma. While nixtamalization is not a microbial fermentation in the strictest sense, it works on the same principle of biochemical transformation that improves nutrient availability and digestibility. Tortillas made from nixtamalized corn are not just culturally significant, they are nutritionally sophisticated. For those interested in bringing these benefits into their own kitchens, home fermentation can be surprisingly accessible. A basic sourdough starter requires only flour, water, time, and attention. Feeding the starter regularly encourages a stable community of yeasts and bacteria that can reliably ferment dough. For rice batters, soaking grains and lentils separately, grinding them, and allowing the mixture to ferment overnight in a warm environment is often sufficient. Even small bubbles and a slightly sour aroma signal that beneficial fermentation is underway. For corn, food-grade calcium hydroxide, lime, can be used to nixtamalize dried corn, followed by thorough rinsing and grinding. Safety and cleanliness are important, but they should be viewed as supportive guidelines rather than barriers. Using clean containers, potable water, and fresh ingredients minimizes risk. Fermented foods should smell pleasantly sour or mildly yeasty, never rotten or moldy. If mold appears in a starter or batter, it should be discarded. Keeping fermentation times within reasonable ranges and storing finished products properly helps ensure both safety and quality. Ultimately, fermentation stands out as a game changer because it works with biology rather than against it. It respects the natural structure of grains while gently transforming them into foods that nourish more deeply and digest more comfortably. Sourdough bread, fermented rice batters, and nixtamalized corn demonstrate that traditional practices were not just culinary choices, but adaptive strategies that aligned food preparation with human physiology. In a modern context, embracing fermentation offers a way to enjoy grains more fully, retaining their cultural richness, enhancing their nutritional value, and supporting long-term metabolic and digestive health without sacrificing flavor or pleasure.